minimum and minimum value of trigonometric expressions. Alright, welcome back to Martin Pen video tutorials, and in this video, that is what we are going to look at. That's what we are going to look at. So first of all, let's start with expressing the function a cos theta plus b sin theta in the form r cos theta plus 1, that is plus or minus. So r cos theta plus or minus alpha, or r sin theta plus or minus alpha. Very good. So how do we do that? So in a question, you will be given this. Okay. So first of all, you put f of x to be equal to a cos theta plus b sin theta, and that's the first thing to do. Then after that, you choose any of it that you want to express in that form. Now, some questions can restrict you. Express this in the form r sin theta plus alpha. No problem, go for it. Sometimes there is no restriction. Sometimes there is no restriction. And at times you can be restricted to r cos theta minus alpha. No problem to that. But if there is no restriction on the question, please note that you can go for any of the expressions that you like. Whether you go for r cos theta plus alpha, or r cos theta minus alpha, or r sin theta plus or minus alpha. Very good. Very good. So that is that. Now, so first of all, you put f of x to be equal to a cos theta plus b sin theta. Then you choose the one that you are going for, right? But you also equate that because you want to express this in the form. So now, for me, I'm using r cos theta minus alpha. Alright? So that means that I will equate this to be equal to this. So we end up by getting a cos theta plus b sin theta to be equal to r cos theta minus alpha. Very good. Now, having r cos theta minus alpha, we know that here the cos theta minus alpha is in a certain form that we are familiar with, and that is cos a minus b. Alright, so we can get this expression from cos theta cos alpha plus sin theta sin alpha. Very good. So you can see, put f of x to be equal to this. Then, since we want to express this in this form, we are going to equate this f of x to be equal to this. So after equating, then we know that cos theta minus alpha is in the form cos a minus b, and that is going to give you this. Then after that, you multiply. You multiply out through it. You multiply out through. So when you multiply out through, then we are going to get r cos theta minus alpha. Hope you can see that. Then r through this, we get r cos theta cos alpha plus sin theta sin alpha. Oh, forgot to bring the r. Very good. So now, that is that. So if r cos theta minus alpha is equal to this, then that should tell you that we will equate this to be equal to this. Because we know that if this is equal to this and this is equal to this, then this will be equal to this. Alright, so let's go for that. So A cos theta plus B sine theta. Please, how we are going through the introduction is the same way that you do when you are solving it. So when you grab some concept here, it will help you when you are solving the questions. Very good. So now we equate A cos theta plus B sine theta to be equal to R cos theta cos alpha plus R sine theta sine alpha. Very good. So now it's like this is identical to this. So if this is identical to this, then we equate the light terms. Alright, so when you equate the light terms, you can see that cos theta is here, cos theta is here, sin theta is here, sin theta is here. So we can equate. Alright, because what we're going to equate, something, what you are going to equate must be in the expression of that so that it can cancel out. So, A cos theta will be equal to R cos theta cos alpha. Then you make A the subject. Then you make A the subject. So when you make A the subject, you get A to be equal to R cos theta cos alpha over cos theta. Alright. Now, why are we making A the subject? I should have explained this to you initially. Now, don't forget that the A and the R, they are quantities that we are to look for. The A and the R, they are quantities that we are looking for. So here, when you make A the subject, you are going to get this cancel this, and A will be equal to R cos alpha. Alright. In the same way, we can equate this B sine theta to be equal to what is here. And when you divide both sides by sine theta, you are going to get R sine alpha over sine theta. Hope you guys see. Oh, sorry. When you divide both sides by sine theta, the sine theta will cancel out, leaving B to be equal to R sine alpha. Oh, nice. Nice. Very good. So now, here, the only thing left is, oh, sorry for this. I mean, the R, in fact, the A and the B will be given in the question, as I said. This and this, the whole function will be given to you in the question. So the A will be known and the B will be known. Alright. But for us to explain this in this form, the R and the alpha here, they are quantities that we are to look for, and that is what we are looking for it now. But the A and the B will be coming from the question. In fact, when we are solving questions, you get to understand it properly. Very good. So I want you to just grab something here, and when you break that, it's going to help you. Alright. So now, after making the A and the B, the subject, please, I like to finish this part. So that's where we start from. This will be given to you in the question, and to express it in this form, you can also choose any other one. But I will always advise you, if what is in the question, the function in the question, if here is plus, when you are going for it, go for cos theta minus 1 alpha, not minus. The reason is that you know for cos, if here is plus, here will be minus. And the minus, if you don't see it that minus here is going to affect the R here, it's going to be another problem for you. Alright, but in case you see it, no problem to it. Okay. So then right after equating, okay, so right after multiplying 2 by R, you know this already. Then you move on to equate this side to what we have here. That is the function coming from the question, and that is that. Very good. So let me play this. Okay. So now we are going to divide. Let me name this equation 1. Let me name this equation 2. So we divide equation 1 by equation 2. So equation 1 is A is equal to R cos alpha. Or let's divide equation 2 by equation 1. I'll tell you the reason why. Equation 2 by equation 1. So now we get B to be equal to R sine alpha. So this is over A, and this will be over R cos alpha. I hope you can see where it's coming from. You divide this A over B, then R sine alpha over R cos alpha. And you end up by getting B over A to be equal to R will cancel out, and we are going to get sine over cos is tan. Is tan alpha. Now watch. Once you divide equation 1 by equation 2, you are going to get cos over sine, which is cos. And I don't want to end up by working in cos, but I want to end up by working in cos. Tan. And that is why I did that. Very good. So now, as I said, the alpha and the R, they are quantities that we have to look for. Alright. So here, the A and the B, that will be known. There will be 5, there will be 2, there will be anything. Alright. So from what we have, that is tan alpha to be equal to B over A. What will you do in order for you to get alpha? That is when you take, that's when you take the tan inverse of both sides. So when you take the tan inverse of both sides, you get alpha to be equal to tan inverse of B over A. So this establishes how we find the alpha. So all this procedure is to help you to get the alpha. Alright. What about the R? What about the R? Now, for R, it's not anything difficult. To get the R, we can use a right triangle. We can use a right, that is a right angle triangle to demonstrate to get that. Alright, that is the idea of Pythagorean theorem. From that, nicely sketched. So the angle alpha, right, theta rather, the angle theta. Now that's how we are going to identify our y, our y, the x, and the r. The r is what we are looking for. Very good. So now you go back to the question. As I said, this will be given to you in the question. So when you go back to the question, please watch. For you to get x is the coefficient of cos. Put it down, write it down. For you to get x is the coefficient of the cos. In fact, we have another alternative way in doing that to get, but I think this is the simple way to go for. The coefficient of the cos theta, and it's always, it's cos theta and sin theta. Always cos theta and sin theta will be in. But what can change is the A and the B. That's why in the general view, we are using A and B. Alright. So here x will be the coefficient of cos, and that is A. Then y will be the coefficient of sine, and that is B. So we go for R. So for you to go for R, then you use the Pythagorean identity S squared. So small r is equal to this. Let's make it like that. So r squared equal to x squared plus y squared. So this one will be capital R squared is equal to S is what? A squared plus B squared. So we get R to be equal to the square root of A squared plus B squared. So please, that is how we find the unknown quantity of alpha and R. The alpha and R. Very good. And after getting that, then you now come back and rewrite. You now come back and rewrite your R cos. You now come back and rewrite. Let's go and rewrite. So later on, you now come back and rewrite. We are bringing everything in this form. So now we know that R is going to be square root of A squared plus B squared cos theta minus alpha. And the alpha is tan inverse B over A. And that is all. Please, I'm advising you, I'm not telling you to go and choose this. No, you don't need to choose this. In fact, just go through the steps and understand it. When you get such, you will be able to do it. Very good, you'll be able to do it. Now, don't forget, let me tell you something about this. You see, the moment you take a square root, you bring plus or minus, alright? For R to be greater than 0, for R to be greater than 0, it means that it will be the maximum. That is going to be the maximum value. That is going to be the maximum value. And for R to be less than 0, that is going to give you the minimum value. So this one is the maximum value. Then this will be the minimum. The minimum value. Alright, so that is how it is. That is how it is. In fact, I would like us to go and solve questions to see how we are going to work through that. Alright, so this is our first question. This is our first question. So we have to express cos 4 cos x plus 3 sin x in the form r cos theta minus alpha. Now we have been restricted here. We have been restricted here to use r cos theta minus alpha. So let's go for it as such. Oh, in fact, I would like to solve the two ways for you. The one that we did is r cos theta minus alpha. So please, I would like to change this to. Okay, we have another question also. All right, then let's maintain it. Or let me add our. The second question says that 5 cos x minus 12 sin x in the form r cos x plus alpha. Okay, here is x, not theta. So since we have x in the function, here is supposed to be x. Very good. So we have two questions there. Let's move on. We have two questions, and here to this we are working to use r cos x minus alpha, and here we are likely to use r cos s plus alpha. And after that, I will show you how to also go with the use of sine, r sine plus or r sine theta plus or minus alpha. We will be looking at that one also. So let's go for this solution. In fact, I would like to do the two so that you do the question one yourself, since we have expressed this before. I haven't expressed this before, so let me go for it. So now, to express this in this form, it means that first you put f of s. I'm solving for question 2. First you put f of s, or don't worry, let's go for all of them. Question 1. So you put f of s to be equal to 5 cos s minus 12 sine s. Then right after that, to express this in this form means to equate s. Oh, I'm sorry for question 1. Here is 4. Okay, so question 1 here is 4. Here is 3. Here is plus. Very good. So you see, only the a and the b change. Only the a and the b change. Alright. Very good. That means that we have to equate s minus alpha. We have to equate s minus alpha cos r cos s minus alpha to be equal to 4 cos s plus 3 sin x. The same procedure as we have already gone through. Then here, we know that cos s minus alpha is going to give you cos s cos alpha plus sin s sin alpha. Then after that, you multiply through by r. So you get r here, you get r here, you get r here. Very good. So now, if this is equal to this and this is equal to that, then you can equate this to this. So 4 cos now, this means that this is identical to this. So we can now equate. So we can now equate the ones in similar expression. So you can see we have cos s here. Now don't just equate like that. Compare these things. We have cos s here. We have cos s here. Oh, we have cos s here. There is no cos s here. We have sin s here. There is no sin s here. So the best choice to go for is to equate 4 cos s to be equal to r cos s and 3 sin s. 3 sin s to be equal to r sin s sin alpha. Hope you can see that. What it says. What is this? 4 cos s to be equal to r cos s cos alpha. Very good. I hope it's clear. Then we move on to, yeah. So we move on to, let me say, make 4 the subject. Like this is representing a here. So 4, we divide both sides by 4. Sorry, cos s. Cos s. So 4 will be equal to r cos alpha. This cancel this. Then we name it equation 1. Then we go for this. Divide both sides by sin s. In fact, always what will be attaching with whether A or B, it must be divided to clear off something. It must be divided to clear off something. This cancel this cancel that. We get R sine alpha. We have named that equation 2. Now I don't know whether you want to work in court or in time, but I will choose time. So I'll rather divide equation 2 by equation 1. Alright, so we divide equation 2 by equation 1. So we get 3 is equal to, so 3 over 4 here. Then R sine alpha over this, which is R cos alpha. And we end up by getting R cancel out sine alpha over cos alpha. This is going to give you tan alpha. And that is 3 over 4. So you can see now here, the A and the B, are known. The A and the B are known. So here, alpha will be equal to tan inverse of 3 over 4. Alpha will be equal to tan inverse of 3 over 4. Or we can say that alpha will be equal to tan inverse of A over B. But please, even though without working, you can just see that alpha will be equal to tan inverse of this, that is tan inverse of this over this. Okay? Because you want to get, if it's cos inverse, it will be cos over sine. So if it's cos inverse, it will be 4 over 3. Now you can see that. This for OBD. Let's say objective, you have to look for the argument for alpha. Oh, then you take, if you want to go for tan inverse, it will be the coefficient of the sine over the coefficient of the cos. If you want to go for cos inverse, then it will be the coefficient of 4 over the coefficient of, the coefficient of cos over the coefficient of the sine. But if it's given to you in a theory part and not objective, please go through all the steps and end up by getting your results. Very good. So when you do that, you are going to get 36.9 degrees. 36.9 degrees. Now that alpha is known, let's go for R. How do we get the R? For us to get the R, small r is equal to capital R. Y is equal to S is equal to. So you go back to the question of f of s. The coefficient of x, the coefficient of cos x representing the value of s, that is 4. The coefficient of sin s representing the value of y, and that is 3. Therefore, r squared will be equal to s squared plus y squared. So, by substitution, s is 4, 3. So we end up by getting r squared, r to be equal to the square root of 4 squared plus 3 squared. And we end up by getting 5 to be our result. That is 5. But don't forget it's plus or minus. So r is equal to plus or minus 5. Now, if you pick r to be 5, that will be maximum. If you pick r to be negative 5, that will be minimum. Alright. But as far as this course is concerned, or as far as this question is concerned, we are not basing on that. So let's go straight to the point to say that we are picking the positive side. Okay, we are picking the positive side. To write it in that form, So to write it in this form, let's go and do that. Because we know, oh, I've filled up the alpha. So now we can now write it that so what is R? R is 5 cos x minus what is alpha? And that 36.9 degrees. You can also make it a whole number, 37 degrees. Very good. There you are. Correct. Therefore, we have concluded that 4 cos x plus 3 sin s is equal to 5 cos x minus 36.9 degrees. Alright, so let me tell you something. When we get to solving trigonometric equations, sometimes you can be given this question for you to solve. And this you cannot solve without expressing it in this form. And when you express it in that form, in this form, then you can solve. I'll try to do similar with you when we are doing solving trigonometric equations. Also, I would like to advise you here also that sometimes you can be given this to sketch. You can be given 5 cos x minus 12 sin x to sketch. With this, you can't sketch it. In this form, you can't sketch it. So you need to express. Nobody will tell you in the question. It will just be sketch this. And nobody will tell you to explain it in this form. Whether cos or sine, you are going to determine it. Okay? So you now express this in this form. And after getting it in this form, you can now go for the graph. Because with this, you can go for the interval and others and sketch it and go your way. Alright. So advise yourself for that. Very good. So let's look at the second question. In fact, I would like you to do this one yourself. Okay? Just be careful when you are equating. The reason is that you don't worry, let me need you some more and get to the other questions. Now we know that here we equate 5 cos. So we put f of s to be equal to 5 cos x minus 12 sin x. Then we equate r cos x plus alpha to be equal to 5 cos x minus 12 sin x. We know that r cos x plus alpha will be equal to r cos x cos alpha. Don't forget, I'm doing 2 in 1 thing. I have multiplied through by r already, and I'm writing the formula. Minus r sin x sin alpha. So you can now equate 5 cos x minus 12 sin x to be equal to r cos x cos alpha minus r sin x sin alpha. Now cos x is inside here. So you can equate 5 cos x to be equal to r cos x cos alpha. And here you can see that 5 will be equal to r cos alpha. equation 1. Now watch. Here is negative 12 sine s and not 12 sine s. Be careful for that. It's negative 12 sine s. Then you equate that to negative r sine s sine alpha. So you can see clearly that the negative will cancel out. And also, sine will cancel sine. Then you get 12 to be equal to r sine alpha. And that is equation 2. Wow, marvelous. Beautiful. So that is that. That is that. So that is the difference here. Hope you can see the difference. Now I'm advising you, if you are to choose it on your own, in the function that will be given you, if here is plus, the one that you are choosing, make it minus. Choose what, I don't care whether you are using sign or whatever, but make it minus. If here is plus, I'm basing only on the sign inside here. If here is minus, choose for plus. The reason is that when you do that, when you equate, it will come and cancel it out. It will come and cancel out. But when you use this for this, it will not cancel out, and if you don't take care, it will end you up in error. Alright? So here is minus, go for what you make here plus. And if here is plus, make here minus. Please continue with the rest, because here, when you divide equation 2 by equation 1, we are going to get alpha to be equal to tan inverse of this straightforward. Because we know when you divide it by this, r will cancel, and you are going to get, this one, so you are going to get 4 over 12 over 5. So that is that. Continue with it and go for your r and the rest. Very good. So the r you get r to be 13. You get r to be 13, and this one too is going to give you 67.4. 67.4 degrees. Then you now go and rewrite it in such form. Alright, so that is that. Let me take you through the one that you expressed to get sine. It seems the question is restricted. Seems it is not. Seems it is. It seems it is not. Alright. Yeah, it's restricted for you to use sign, but for it to be plus or minus, the question says it depends on you. So do it for yourself. Very good. So it's your choice. Now let's go. We start to put f of x to be equal to 3 cos x plus sin x. Then that means that we can equate. Okay, are we to go for minus or plus? So now watch. Here for sine, can see that how we are watching. Here is plus, so we'll go for minus. It should be opposite. Don't choose the same thing. Okay, so minus alpha. Then you break down to 3 cos x plus sin x. Very good. Now, please, I would like to add this. You know that when you express, I'm still coming to explain this to you, whether to go for plus or minus. For cos, the sign should be opposite. If here is plus, make it minus. If here is minus, make it plus. But for the sign, make it plus. The reason is just simple. Watch, watch, watch. When you express sine s plus alpha, you don't change this sign. You don't change this sign. So this you get sine s cos alpha plus cos s sine alpha. So for that reason, you are going to get this in terms of plus. So in the same way, if this in the same way, this one too is in terms of plus. So comparing this to this is going to ease your work than making here minus. Oh, no problem. You make here minus, here supposed to be minus. And when you compare this to this, you may end up in error. But if you know the trick, you can go for it. But for me, I'll make here plus. Make here plus. So if it is sine, if here is plus, I will go for what is plus. If here is minus, I will go for what is minus. But of course, it's opposite. Simple. So we equate it to. Alright, so let's multiply 2 by r. Hope you guys see the mistake. Alright, so now check. Here, take a pen, take a pen. Unlike the one in cos, when you express the cos, everything here will be cos, everything here will be sine. But here it's not like that. Here is sine cos, cos sine. So take your time. What is here? Cos s. Right? 3 cos s. So this is identical. You are going to equate it where you can see cos s. So it's cos s here? No. Cos s is not here. What is here is cos alpha. So don't go and equate to 8. Are you watching? Don't go and equate to 8. Take your time. Is cos s here? Yes, sir. Cos s is there. So you equate r cos s sine alpha. Then you divide both sides by cos s. Cos s. As I said, it must cancel out. That is why it's supposed to be in this expression. So 3 will be equal to r sine alpha, equation 1. Then you go for sine theta. You see, since here is plus, here is plus, I have you need to just free your mind from such, because here is plus, here is plus. So I'm not even think of it whether it's actually going to be plus or minus. So that is going to ease your stress. Very good. So sine x is going to be equal to, you can see that sine x, and we have sine x here. There is no sine x here, but there is sine x here. So r sine s cos alpha. Now you divide both sides by sine s. 1 is equal to r cos alpha. So that is equation 2. Now for you to find alpha, you know what to do already. You need to get time. So this one, you see, so it's not always equation 2 over equation 1. If you want to get time here, it's supposed to be equation 1 over equation 2. So equation 1, 3 over 1 is equal to r sine alpha over r cos alpha. So that this cancels this, then you get tan alpha to be equal to 3. Tan alpha to be equal to 3. And alpha will be equal to tan inverse of 3. tan inverse of 3. Please take a calculator, punch it, and continue. When you are done, then you go for R. So to go for R, you use your right angle triangle. So the value of S is going to be 3. R is unknown. Y is going to be 1. That's the coefficient of S. That's 1. Then you go for it like that. Very good. I think that is all. I'll leave the rest for you to go and try. Alright, so continue with this one. Continue with this one and conclude it. And go and try on this equation. And I'm going to make it open for you to choose what you go by. 6 cos S plus 5 sin S. Negative 2 cos S minus 3 sin S. Choose any of it that you like, whether R cos S plus or minus alpha or R sin S plus or minus alpha. Thank you. See you in the next video. Alright, let me add this in this video. That is solving equation in the form A cos S plus or minus B sin X. Very good. So, looking at what we have on the board, solve the equation cos S minus square root of 3 sin S is equal to 2. For S values in the interval 0 degrees, that is S less than or equal to S greater than or equal to 0 and less than or equal to 360 degrees. Very good. So now, the first thing to do is to express cos S minus square root of 3 sin S. Okay, so now we have this in the equation, but we can't solve for this unless we express cos S minus square root of 3 sin S, and that is the left hand side in the form that we just talked about. So whether you go for R cos S plus or minus alpha or R sin S plus or minus alpha, any of it that you like to go by. And I have taught you the technique that if here is minus and you are going for the sign, make that place R sin S minus alpha. That is, if you have here to minus, it should be the same thing. But if you want to choose cos, if here is minus, make here to be plus. Make here to be plus. Very good. So let's go for that. We know that R cos S plus alpha is going to be equal to R cos S cos alpha minus R sin S sin alpha. Sorry. Then we go and equate this to this. Because after we get it in this form, we can now equate to 2 and go our way. So now let's equate cos S square root of 3 sin S to be equal to R cos S cos alpha minus R sin S sin alpha. So cos S is here, and we can see cos S here. So here you can get 1 is equal to r cos alpha. Then you name that equation 1. Now, here is minus, here is minus. So forget about the sign. Square root of 3 sine s will be equal to then you divide both sides by sine s. So for you to get it in time, divide equation 2 by equation 1 so that you can get sine alpha over cos alpha. So this is square root of 3 over 1, which is equal to r sine alpha over r cos alpha. This cancels this. So you end up by getting tan alpha to be equal to square root of 3. Therefore, alpha will be equal to tan inverse of square root over 3. And tan inverse of square root, tan inverse, okay. So tan inverse of square root over 3 is going to give you 60 degrees. 60 degrees. Sorry, yeah, tan inverse of square root over 3 is going to give you 60 degrees. Alright. So here you can choose to leave it in degrees or in radian. Radian will be pi over 3. Yeah, radian will be pi over 3. So let me say 4 pi over 3. Very good. So after that, then you go for you go for your r. The coefficient of cos is 1. The coefficient of sine is, you can see that is negative square root of 3. And then r. So r will be equal to, r square will be equal to 1 square plus negative square root of 3 all square. And r square will be equal to 1 plus. Here you get 3. Okay. So r square is equal to 4. So r is equal to the square root of 4. And that is plus or minus. So that is going to be, and we are going to pick the positive side. So we get 2. Very nice. Now let me show you how to solve it. So now, all that we are going to is what we have done before. So we are now coming to solve the equation. So we are now going to write it in the form r cos theta, r cos s minus r cos s minus, oh, where is this? Oh, s minus alpha, and we have alpha to be less than 60 degrees. And we know that our r is 2. We know that our r is 2. And this is equal to cos s minus square root of 3 sine s. So now, we are saying that this is the same as this. So if this is equal to this, then 2 cos s minus 60 degrees will be equal to 2. Exactly that. So when you divide both sides by 2, or when you multiply both sides by half, you end up by getting cos s minus 60 degrees to be equal to 1. Alright? And we can now do for that. Now here we take cos inverse of both sides, so s minus 60 degrees is equal to cos inverse of 1. And cos inverse of 1 is 360 degrees. So here s minus 60 degrees is equal to 360 degrees. So here we end up by getting 360 degrees plus 60 degrees. And that is I think there's a mistake somewhere. Where is the mistake coming from? Where is the mistake coming from? Oh, please check this one for me and do the correction. Okay. Tan inverse, yeah. The tan inverse of square root of 3. Check that one for me. The tan inverse of square root of 3. So you use that angle you get, the alpha you get, use it and go through the same procedure, and your final answer is supposed to give you 300 degrees. Your final answer is supposed to give you 300 degrees. So I think the tan inverse, yeah, the tan inverse of square root of 3 will be giving you negative 60 degrees. That's going to be negative 60 degrees. Alright? So this negative 60 degrees will be here. So here, if you are bringing negative 60 degrees, here will be plus. If you are bringing negative 60 degrees, here will be plus. Here will be plus, here will be plus, here will be plus. And when you take this one to this side, here you will subtract. So you end up by getting 300 degrees. Sorry, in case sometimes I make a mistake. In fact, sorry for that. Very good. It's not easy to be in front of a camera and be teaching like that. Very good. Thank you. And see you in the next video. So that is how we solve for such questions. But please, I would like to let you know this. I would like to let you know this. Please, I'm still advising you. For instance, when you are given this to sketch, know that before you can sketch for this, you have to get it in this form. Okay? So when you are doing this to sketch, go through the same procedure and have it in this way. Whether the sign or the cross, before you go and sketch it. Because with this, you can't see the maximum well and you can't see the minimum well. And even the interval, when the interval is going to be somehow difficult for you. So when you pick it like this, then you go your way. You can choose the angle to be degree or in gradient, or it's accepted. Thank you, and see you in the next video. In the next video, we are going to look at, I think that is still another topic, but I want to split it into two. Yeah, we are now coming to look at how to find the maxima and the minima value of trigonometric expressions. In fact, even that, I want to add it in this video. Let me add it. Let me add that so that it will all include one video. Yeah. Okay, or in the next video. Let's go to the next video to do that. Thank you. So let's look at how to get the maxima and the minima value. Now don't forget, when you multiply the coefficient of sine theta or cos theta by 1 and negative 1, you are going to get the maxima and the minima value. So when you multiply the coefficient by 1, you get the maxima. It will give you the maxima. When you multiply by negative 1, you get the minima. I hope it's clear. Very good, that's how it is. So for question 1, if y is equal to 2 sine theta, if y is equal to 2 sine theta. Now, having this, when you multiply -1 by 2, you get -2. And that is the minima. And that is the minima. How you can see that? Very good. And when you multiply 1 by the 2, that you get 2. And this is the maxima. And this is the maxima. Like that. Very good. Now, sometimes too, you can get it in the form if 4 cos s minus pi over 4. Here too, the coefficient is 4. So when you multiply -1 by 4, you get -4, and that is the minimum. And when you multiply 1 by 4, that is 4, and that is the maximum. I hope you can see that. Thirdly, we can get -3 cos half s plus 4. Now here, we are having something introduced here. And that, so with the third question, there is something new introduced here, and that is the vertical shift. Unlike the first, for example, there was no vertical shift. Here the vertical shift is against 0. But here there is a vertical shift of 4. And that is upward of 4. So here to find the maximum, you are going to add 3 plus the 4. The result you get, you multiply by 1. That gives the maximum. So here you get 7. So 7 is the maximum. For you to get a minimum, for you to get the minimum also, what you do is that you multiply. Now, let me emphasize on this one. Even though you get the same result, but let's do the right thing. You multiply 1 by the 3, alright? Then you add it to 4. So we are going to do it that way. Multiply 1 by the 3, then you add it to 4. And this is going to give you 7. And that is the maximum. For the minimum, you multiply this 3 by -1, then you add it to 4. And you can see the difference here. This will give you -3 plus 4, and the result is 1. I hope you can see that. Very good. But if you add before you subtract, if you add 3 to 4, you get 7. When you multiply by -4, you get -7. You see, it's not the same. Even though for the maximum it's not affected, it's still 7. But that concept may be bringing you to the minimum also, and that's going to be very good. So always do the right thing. So that is that. Let's look at the fourth example. Let's look at the fourth example. You can also get a function very good. I like it. I like it. Now, if you have a function like this, which one is going to be the maximum? Which one is going to be the minimum? The question is 4 cos s plus 3. Let me write it for 4 cos s plus 3 sin s minus 3. Very good. So here, first of all, before you do anything, you have to rewrite this in the form. You need to rewrite this in the form f of s is equal to, for only this part, you express that in the form r, okay, reduce r cos. If you choose coordinate class, you will make it s minus alpha. Then the vertical shift is not included, should not be included to this. Then the vertical shift will be minus 3. Alright? So only this, the whole of this can be expressed in this form, but you can express only this part to this form. Then we bring the minus 3. Very good. In the same way, I'm still emphasizing on this. When you are giving this to sketch, when you are giving this function to sketch, leave it in this form. And that will be similar to what you have been sketching before. I haven't taught you how to sketch this. You can't do this unless you leave it in this form. Alright. So let's use the short method and go. We know that the r is going to be the square root of the coefficient of this and this square. So that is 4 squared plus 3 squared. And that's going to give you r is going to be 5. So r is 5. And you can also use the short method to get alpha. And that will be the tan inverse of, we are using tan inverse, so it will be supposed to be sine over cos. So the coefficient of this is 3 over 4. So 3 over 4. This is a short method to do that. Alright. So when you take the tan inverse, okay, so when you take the tan inverse of 3 over 4, whatever you get will be for the alpha. But here, the emphasis we are looking at here, the emphasis or the content we are looking at here, even if you don't know for the alpha, we can still go for it. So take a calculator, punch that, and you can go and write. And when you write that, then you get 5 cos s minus alpha. And the alpha, go for 8 yourself, very minus 3. So I'm saying if the alpha is 30 degrees, that is pi on 6. And with that, you can go and sketch it. But this is minimum and minimum, so let's move on. So for you to get the Messi, after this, for you to get the Messi, that will be 1 times 5. Then, don't forget, you add that to the vertical shift. When vertical shift is negative 3. And here we get 5 minus 3, and that is 2. So the maximum value is going to be 2. But for the minimum, we multiply negative 1 by 5. Then we add it to the vertical shift. So here we get negative 5 minus 3, and that is negative 8. Yeah, so for the minimum, we get negative 8. Alright, please continue to try your hands on the rest. Please keep on emphasizing on this. To sketch the whole of this, leave it in this form. The same way, to solve the whole of that, leave it in that form. To solve, yes, you still leave it in that form before you can solve it. Now, continue for this. Try 6 plus 3 cos s plus 4 sin x. 6 cos s minus sin s plus 3. Then 7, I may help you with the 7 parts. 1 over 4 cos theta minus 3 sin theta plus 6. The whole of that is on the denominator. So please do this and this on your own, the 5 and the 6. Don't forget, this part is present in that part. This part is present in that. In fact, it's very, very important. So let's look at the seventh one together. As usual, this part, you're going to express it in R cos S minus, here is minus, so S plus alpha plus 6. So we are going to express it in this. Okay, very good. So let's go for R. The alpha is not important here. That's not the emphasis here. So to get the R, we go for this. The coefficient of the cos is here. This is here. Then we go for R. So R will become to the square root of negative 3 squared plus 4 squared. Whether 4 squared plus 3 squared, still the same thing. And with this, we are going to get R to be 5. We get R to be 5. Very good. So, don't forget, when you take the square root, it's plus or minus, plus or minus. Okay. So for it to be maximum, it will be positive. For it to be minimum, it will be negative. But we are saying that for it to be maximum, and we are having the vertical shape there, you know that here you multiply 1 by the 5. Then you add 8 to 6. And this gives 11. And for the minimum, the same way, because that is going to be positive 5. That's the maximum. And the minimum, when you multiply this by, this is going to be negative 5. And that is the minimum, plus or minus, square n. Then you add it to 6. And this is going to give you 1. That's going to be 1. Alright. But don't forget, this is 1 over the whole of this. So when you are done, then you come back. Therefore, the maximum will be 1 over 11. Then the mini will be 1 over 1. And that is what you're going to get. Please don't end here. Don't end here. If you end here, you are wrong. Because it is 1 over the whole of that. Very good. Thank you. And see you in the next video. In the next video, we are going to talk about inverse of trigonometric functions, and surely you will see you there.